Monday, Tuesday, Wednesday, Thursday, and Friday. Welcome to Mr. Hall's virtual classroom. I'll be your friendly host, taking you through the pandemic at home virtual classroom, learning all those mathematical needs in the privacy of your own home. So, my dear sweet friends, as we all gather together in the virtual world here, I ask you, join me, 7th graders, my dear sweet loved ones, on page 328, as we dive into the basic geometric figures. That's right, my friends, the basic geometric figures. So, if you would, turn to page 328 and we'll get started. So, when we're talking about geometry, we're talking about the study of shapes formed by points, planes, or just space taken up. So, you guys have seen geometric figures ever since you've been in kindergarten, whether it be triangles, squares, or circles. Geometry is all around you. So, we're going to dive in, if you would. So, make sure you're on page 328. First of all, we're going to talk about just some different representations and symbols of geometric figures. So if you'll go down to definitions, we're going to start right in with array. So array comes to either point. You can have a point on the left or you can have a point on the right. So I'll draw them both ways, that way you guys can see. So one thing that you're going to notice is when it comes to a point, say right here or right here, that means it can go no further to the left on the top or it can go no further on the right and the bottom. But when you see the arrows pointing, that goes into infinity. That means this right here will never stop, this will never stop. But right here, these points, they're just like periods of a sentence. Over. So let's also look, if you would, at a segment. Now a segment is a portion of a geometric figure. So if we have a line, our segment could look something like this. You see these periods? That means, or dots if you will, that means it will go no further to the left or no further to the right. If we were to use that into an example, a square. A square has how many segments? Well, let's count them up. Can't go no further here, 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 or here. So how many segments do we have? 4. Use the square because it's most simplistic as being able to just kind of look at it and get a better understanding of a segment. Now an angle, here's where it might get a little more trickier, if you will. An angle is going to be 2 rays. Okay, so what did we say rays were? Well, let's draw our rays again. Two rays that have a common endpoint. So if you were to have, let's say we were giving, and I'll write this so you can see a little better. If it said we have angle, and this is a symbol for angle, A, B, C. Alright, now let's go back. We're going to look at our rays. We're going to show what they're going to look like if they were connected. So what that means is you're going to have A, and you're going to have B, and you're going to have C. So A, B, C. And the way you're going to look at this is you're going to read it a little bit different than when we just looked at the rays by themselves without segments pinched in between. So the ray here is going to be B to infinity. But the segment is going to be B to A, and the segment is going to be B to C. So if I say B to A and B to C, what did we repeat twice? What variable, if you will? So we said B. So A is sharing B, and C is sharing B. So that means our vertex or angle is going to be angle B for the vertex, because that is going to be the common endpoint that they're both sharing. So C isn't sharing A because there's no connection. It's kind of like, if you look here, the mediator. So just a quick recap. Let's go back and say those one more time if we could. Segment, ray, angle symbol, vertex. So if we have the vertex is going to be whatever point lies right here. Okay, if you would, let's go ahead and look at example 1. Example 1 says, draw a picture of a segment, then write the symbol. Okay, let's go ahead and look. So since we're drawing a segment, how many points does it have? 2. And if you look in your book, you see they chose to use D and E. So we'll put D and E. Or you could read it E to D. But in doing so, you want to focus on 2 main things. You want to make sure that you have the symbol that represents what a segment is. So if you were to write that, here's how someone would know what you were talking about. The symbol would be a line over the top of whatever 2 endpoints you chose, or you can write it vice versa and we give E to D, and you still get the same answer. Alright, I'll let you guys work on skill check 1 for a moment. And you can pause this video while doing so. But we're going to go on to example 2. It says, which geometric object does a yardstick best illustrate? Well, does a yardstick go on forever? No. I mean, if we're looking at a yardstick, we're looking at something that kind of probably looks like this. So even though it doesn't look like this, per se, does it come to an endpoint on both sides? Yes. So some of this stuff you'll have to use, deductive reasoning. I mean, it doesn't go on forever to the right. It doesn't go on to the forever to the left. So what does that say to us? It says, oh hey, looks like we have a common endpoint. So what would you guys classify that as? A segment. So a yardstick will be considered a segment. Now I want to let you guys pause for a moment and go ahead and take a look at your skill checks. One thing I do want to touch base with you guys too is a plane, which I want to talk about that before you actually do your skill checks. I want to apologize for that. A plane is a flat surface, not an airplane, but just a plane. Is a flat surface in which things reside, such as maybe if you had points in this plane here. What do you guys call this? A segment. That's a segment within this whole plane right here, the square. You can have a ray inside there, or guess what? You can have your angle inside there, terminal rays. So if we go to skill check 2, with that information given to us, it says, which geometric object best illustrates the following? Well, a soccer field, a field would be a plane which held the soccer ball, the soccer players, the goals. So we would consider a soccer field a plane. It says a place where 2 walls meet. Well, if a place where 2 walls meet, let's just draw 2 walls. They can be like right here. Basically what you're going to say about those are going to be a line. And that takes me back, if you will look at the very front of page 328, where you have your basic geometric terms, your point, your line, your plane. So again, a point is a location in space with no length, represented like this. A line is a set of points along a straight path with no endpoint. So that means it can go on forever right here, but you can have endless amount of points across there. Take us back to the wall. the wall keeps going, but here's a point in the wall. Or if it wanted to go this way, we could have a point here. Nonetheless, we see a line is formed. Now, if you look also in your basic geometric terms, back to the plane. A plane is a flat surface that extends endlessly in all directions. That means it can go forever this way, forever this way, forever this way, and forever this way. So what it is doing, as we mentioned earlier when you had your first skill check, a soccer field, it's housing your players, your soccer goals, and referees, whatever you want to say is on there. But if you will look a little closer too, it does look like a square, but you can't say it is a square. You have to say it's a plane, because a square stops with these points, segments, like we talked about earlier. A plane goes on forever. Alright, now we're going to be looking at different variations of angles. If you'll look now on page 330, we're going to take a little look at using a protractor. And you guys are going to learn how to read it. And allow me to say a little more, you're going to be using this throughout the rest of your mathematical career. Alright, so shall we get going? If you look at the first on page 330, you see the protractor. Luckily for you guys, you won't need none in this exercise. It already gives you the protractor, so you're just basically going to look and tell me what you see. So it says the measure of angle ABC. So what that's saying is, I want to draw this really quick. Excuse my drawing is terrible, but what that is saying is, on a typical protractor, it has an arm on it. If it goes straight up, you can move to the left or to the right. But if you just have a basic generic one, you just have to pretend it's there. So, if we look at which way the angle is pointing, well, it says the measure of angle 35. So, you're going to look, and we see where it says 35 to the right. Now, typically, one thing I want you to realize, a perfect line in degrees, so that means this is 180 because it's perfect with this side, 180. So if this is 180, what would you guys think the middle portion going up right here is? It would be 90 because it would be half. So that means this side will be 90, and from here to here is going to be 90. So basically we're going to look at finding 30 and finding 140. Now, one thing I want you guys to realize also is you can read it two different ways. The top is going to read from 10, 20, 30, 40 from left to right, and the bottom is going to read from right to left. So if you're reading, I want to write portions. If you're reading from here, the top, you're going to read from 0, which will start right here, 0, all the way to 180 right here. So from 0 to 180 in increments of 10. Now, the same thing applies here if you're reading from, I may have said that backwards, so let me just back up one more time and re-say that. Okay. So, let's just do the left. If you're reading from the left, top left that is, you read from increments of 10. So it starts at 0 right here, all the way to 180. Now that's the top in increments of 10. Now if you're doing the bottom, which is underneath all this, right here, you still read from here, it's 0, and it goes 0 to 180 in increments of 10. So if we'll look at our definitions, acute angle is less than 90 degrees. So that means a 90 degree angle looks like this. it can form a perfect square inside of it. An acute angle would be something similar to this because it houses something smaller than 90 degrees. Now obtuse is going to be what? Greater. So it would be something that looked more like this. Can you draw a perfect square in there? No. So this is obtuse. So I'm going to put G90. I'll put 90 and L90. And what that says is this is greater than 90 degrees for obtuse. The right angle is perfect 90, and acute is less than 90. And what I say about a line equals 180 degrees. So, just quick references because these will be used throughout the rest of your mathematical career. Woo, yeah, alright. Guys, we just got a surprise. We're about to do skill check 3. Alright, with that being said, let's look at the measure and classify. So again, friends, we're going to look at VRT. So I'll try to do my very best to draw this, which again, my drawing abilities are usually lack thereof. So R, and this is going to be S. It's going to be V, T, and U, and Q. Now, bear in mind again, friends, this is not the most accurate description for me to draw. So I'm just like freehanding this. But one thing I want you guys to see, if you will, again, I apologize for the terrible arts ability I have. VRT. So what we're going to read is, let's find V. Okay, here's V, here's R, here's T. Well, I'm going to go ahead and write this up for that way you know this is 90, 180, and 180. Well, let's see. Is V... Actually, I'll tell you what I'll do. I'm going to change colors here. That way it might be a little easier to see. Is V, R, T greater than 90? So 90's right here. No. So what kind of angle would you say that was? It's acute. And you'll have to look on your protractor because I obviously can't draw well enough to show you guys. But so VRT, you look over there and it's at 60 degrees on your protractor. Now let's look at URV. URV, so URV. Well, is that 90? No. It's less than 90. So it is what? It's another acute angle. What did it fall on our protractor? Well, to me it looks like it's at 35 degrees. Next question, SRQ, 50. It says acute angle. Because why? Why would it be acute angle? Let's do SRQ. SRQ. Did it go up to 90 here? No. It is less than 90. So it is also acute. And if we look at our protractor, it is at 50 degrees. Alright, and the last one for your skill check says TRS. Let's find T. Okay, here's T. Let's find R. And let's find S. And let's just do a different color. So we got T, R, S. Well, to me, it looks like it's going to be a little wider than a 90 because you can't form a perfect what? To be a perfect square, it would have to be S, R, and we weren't given one to make 90. I just wrote that. But this isn't, so it will be what kind of angle? Obtuse. And how many degrees? Well, let's look again here on our protractor. SRT falls at 120. Alright guys, so hopefully this wasn't too big of a train wreck. You'll be able to go back and look. It's, like I said, it's a learning experience, but I just want to say thank you guys for all the motivation, and I'll be giving you your homework assignment just in case you weren't able to see it at the top. So thank you guys for tuning in, and alright, yeah. So it looks like your homework is going to be a 8.1 on page 331, and it will be 1 through 33 odd. 1 through 33 odd. And also for tomorrow, what I'm going to have you guys do, and I'll just go ahead and write all this down so we can see it. So for Wednesday, HW is going to be page 331, 1 through 33 odd. And then for Thursday, we're going to I want you to keep practicing this because, like I said, this is not just your typical day in the classroom, so you can have a little more practice with this. We're going to do on page 331, and it's going to be 2 through 34 even. So, again, this is, should take care of you through Thursday. And if you guys have any questions, feel free to contact me, and I'll, like I said, I'm going to be posting all this stuff on Facebook and make sure that you guys get all this, whether it be through email, Facebook. You guys have my phone number, and we'll make sure that we stay in touch. So I guess with that being said, my dear friends, I'll see you guys later.